Okay, ladies and gentlemen, let's take a look at volume of a pyramid. Now, volume of a pyramid. We'll start with something like this. This obviously is not a pyramid. This is a prism. So, the way you get a pyramid is you take a prism, and from that prism, you take a point on one base, and you draw a line to each corner from that point until you have what is left is a pyramid. So we have a pyramid. Now, we already know the volume of a prism. The volume of a prism is base times height. So base times height. Volume of a pyramid is going to be 1/3 base times height. And that's going to be for a pyramid. Okay, 1/3 base times height. Now, if you're in geometry class, I actually have you go through and do a proof of why it is a 1/3 of base times height. But for most cases, we'll just buy that it is indeed 1/3 base times height. Here's an example of a pyramid. Now, you'll notice this pyramid is not a base with a rectangle. This base actually is a triangle. So just like you can have prisms that are either square bases, you have other square bases, different size, you can also have this prism. This is a pretty classic prism here. It is a right prism because each angle here is 90 degrees. Hey, I can even write on that, 90 degrees. So that works, and they all come up from a base, but this base is clearly a hexagon. So in this case, a hexagonal prism. I could have a triangular prism, but I don't. Okay, I have a triangular pyramid. I could have a prism for a hexagon. Okay, or again, if I take that dot and I go to each thing, I could have a hexagonal pyramid if I go to each, do I go to the center dot? If I have a triangle and I go up from each corner, see, I can have a nice prism. Or if I take my dot and I go down to each place, I now have a triangular pyramid that looks a lot like that. Now, the thing about it is, how do you know that it's actually 1/3 base times height? Well, in this case, let's assume I have this one, and I have a ruler. And this, I already know what it is, but just to show you, 3.5 inches by 3.5 inches by, it should be 1 3/4 inches. Yes, it is 1 3/4 inches. Cut it myself. So in this case, if I have volume equals base, which is length times width, so 3.5 times 3.5, times height, which is 1.75, I can find the volume of that prism, 3.5 times 3.5 times 1.75, and I come up with 21.4, basically 21.43. That's the volume of the prism. Now, if I had a pyramid, I would do exactly the same thing. I would have the same base. I would say 3.5 times 3.5 times the height, which is 1.75. Okay, 1.75. But now in this case, I would need, because it's a pyramid, 1/3 of that, or take this and divide it by 3. So I take 3.5 times 3.5 times 1.75 equals, divide by 3. Answer is 7.15, basically. 7.15. And if I multiply that by 3, it takes me right back where I was, 21.43. So that's the volume here. And what I have is I have a pyramid, and that volume is 1/3. So let's take a look. Right here. Same size shaped block, okay? In fact, the bases are exactly the same because they in fact were the same piece of wood till I cut them. So it's the same bases, and they're going to be the same heights. So here we go. Same heights. So same bases, same heights. The only difference is this one I've cut up. And so I have a pyramid that comes out. Now, by the way, if this pyramid is exactly 1/3 of the volume of this prism, that means all these bits over here are actually going to be 2/3. So 1/3, 2/3 should equal all 3/3. Well, here we go again. Let's go back and get our volume, and let's go do it by displacement. And so to use displacement, got to take my quarters out from the last video. I take this, and it currently has 600 and, well, currently basically 600 milliliters, little under, okay, little under 600. What I'm going to do is I'm going to take the block and I'm going to submerge it. Nice thing about the block is it should be fairly easy to do. Okay, so in this case, I have submerged the block. Doesn't matter how deep I go, I just don't want my finger to take up more displacement than is necessary. So at this point, I clearly have 900 milliliters. 900 milliliters. So the difference between 600 and 900 would be the volume of the prism. So I have prism. That was 900 milliliters minus 600 milliliters is going to be 300 milliliters. That's going to be milliliters, which, by the way, milliliters is a volume, just like if I went and bought a big thing of Coke or a big thing of Pepsi, it's going to be a 2-liter bottle. Well, a milliliter is simply 1/1000th of that. Now, if we're estimating our pyramid, instead of being 300 milliliters, should be approximately 100 milliliters, because it should be exactly 1/3 as big. So let's find out. Now, for good method, we want to make sure we look at our numbers, because you'll notice I did take a little water out with that last block. But I think if we get it to settle down, we're going to be right at 600 again. Maybe slightly below. Yeah, it looks like we're going to be slightly below 600 because I lost a little when I took the other block out. So if we did that, let's put this in. And we should have, again, if it's 100, we should have right at 700 milliliters in the block. Now, I think we already have a really good sign here. If I push it down such that it just goes below the water, kind of tough to push down, I go right at 700 again. So instead of 600, we're at 700. Which makes sense. By the way, you notice it popped up, and so it takes up less volume. So we have 100. Now, that makes sense. Again, if we're talking displacement, I want to make sure I let all the water drip off. If we're talking displacement, that means that all of these bits, all of these cutoffs that I made to get my cone or my pyramid should be equal to, well, instead of 300, it was 100. So the non-pyramid parts should be approximately 200 milliliters. So we should be, if we started at 6, we should be somewhere near 8 at this point. So let's see how we did. Well, that's only 7 there, but you'll notice a bunch of stuff is setting up out of the water. So let's see if we can get it down in the water and see where the water goes. And the answer is, I got them all in there. I do have them all in. We are slightly under 800. We are slightly under 800. And so at slightly under 800, let's take out the pieces. Let the water drip. Now, you'll notice we're slightly under 600. So we went from slightly under 800 to slightly under 600. That's going to equal 200 milliliters. And again, with 200 milliliters, you take the pyramid plus the parts that are not pyramid, and you get the total volume of the prism. So, again, it would work whether the pyramid is straight up and down or whether it's not. So, if I had this guy right here, let's take a look at this guy. This guy is indeed a pyramid because it goes from some base and it goes up to some point. Okay, now, unfortunately, my little point came off a little bit, but we'll just have to live with it. So, in this case, let's trace it. Okay, and we also knew that the block that it came out of was 1 3/4. So we know that it should be 1 3/4 tall. This should be 1 3/4. In fact, oh no, that's right, because it goes cut through. In this case, we get 2 and it looks like 1/8. This one we get 2 1/8. So at 2 1/8 and 2 1/8, 2 1/8, 2 1/8, we have a right triangle for a base, so volume equals 1/3 big B times H. The base is actually a triangle, so we would say 1/2 of 2 1/8 times 2 1/8 times the height, which is 1 3/4, and take it times 1/3. That should be the volume. Your job for homework is to find this volume. So I want the triangle pyramid volume, and I want to know for B, what would be the volume of the prism it came out of. So if this were a true prism again, and it were all the way across, a triangular prism, which would look like this, what would that volume be? All right, there you go, folks.